All right, let's go ahead and talk about our lesson today, 5.5, the triangle inequality theorem. So there's one theorem here that we're going to use today, and it talks a little bit about the sides of a triangle. So let's go ahead and read this definition here. It says, the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So as you can see in this example here, we have triangle PQR. And then they take these three inequalities. And remember, if you don't know what an inequality is really just a greater than or a less than sign, right? That in any statement with a greater than or a less than sign is an inequality. And what they say here is they say, hey, if we take the sum of two of the sides of a triangle, and as you can see, they have it 3 times here. And that's because they have to make sure they get every combination of two sides that they can possibly have. So anytime we have two sides of a triangle and we add that together, that should always be greater than the third side of the triangle. Okay? So basically what this says here is if the two sides of our triangle add up and they are not greater than this third side of the triangle, that means that this would not be a possible triangle. So let's go ahead and do a couple of examples here to make sure that we know what we're talking about. So is it possible to form a triangle with the given side lengths? If not, explain why not. Well, in this example here, we have 8, 15, and 17. What we have to do is we have to create 3 inequalities that show that every time we add 2 of the sides of a triangle, that it is always greater than the third side. So we have 8 plus 15 here. Those would be the first 2 sides. We have to show that that is greater than 17. So 8 plus 15 here, this is going to be 23, and we know that 23 is definitely greater than 17. Now let's do our next 2 sides here. 15 and 17 has to be greater than 8. Well, that should be pretty straightforward there. I know that when we combine these two, they're going to be greater than 8. So 32 is greater than 8. And then lastly here, we got to do our first side and our third side. So 8 plus 17, we have to show that that is also greater than 15. So 8 plus 17 here is going to give us 25. And yes, of course, 25 is greater than 15. So we showed 3 different inequalities here. And if you notice, the second half of those inequalities were each a different number every time. So if you always want to make sure that you've got the 3 inequalities set up correctly, as long as your third number, the one on the right-hand side there, is different in all 3, that tells you that you have done the right thing. Okay. Now, since all 3 of these inequalities checked out, we are going to say yes. This is a triangle. All right. Yes, this is a triangle. Now let's go ahead and take a look now at our second example. We've got B. We're trying to do the same thing here. Is it possible to form this triangle with side lengths 6, 8, and 14? So we've got to basically do the same exact thing here in our second example. So we're going to start off by saying 6 plus 8, we hope, is greater than 14. Now, when we actually do this out, we get 14. And what do we know here about 14 and 14? Well, 14 is not greater than 14, but 14 is equal to 14. Okay, so remember, we had to show that they were all greater than the third side. Well, here, they are not greater, right? They are not greater. They are equal. Okay, so what we're going to do now is we are going to say no, not possible, because 2 sides added together equaled the third side. So no, not possible, because 2 sides added together equaled the third side. All right, so hopefully you can kind of get an idea as to how this works. Remember, just if you show that the first 2 sides are greater than the third, and that checks out for all three of your inequalities, then you're good. That's a triangle. But as you can see, anytime it's not greater than, so whether it's equal or whether it's less than, anytime that's not the case, we are going to have to say, no, this is not a possible triangle. Let's go ahead and talk about this question. It says, find the range for the measures of the third side of a triangle given the measures of two sides. So we've got these two numbers here. We've got 5 and 11, but we don't know what the third side is. So what we need to do is we need to set up some inequalities to help us solve for that. So we're going to say x here. We're going to say that our third side is x. And this is what we're going to need to do. We're going to have to make two inequalities here. One with x on the left, one with x on the right. So let's go ahead and start off here by saying 5 plus 11 has to be greater than x. Okay, 5 plus 11 has to be greater than x. Now the second inequality here, what I want to do is I want to add my smallest number to it. So in the first inequality, I wanted x to be on the right-hand side. In the second inequality, I want the biggest number to be on the right-hand side. So I'm going to say 5 plus 11 is greater than x. I'm also going to say x plus 5 is greater than 11. All right, so remember that one that goes on the right-hand side there, that is just going to be the biggest number. The biggest number or the biggest side. So our biggest number here is 11. So we can go ahead and solve these inequalities. Now, a lot of people forget how to solve these inequalities. This is no different than if we're solving this with an equal sign, okay? We're just going to treat this as if it was an equal sign. So we see here we can combine some like terms. We're going to combine 5 and 11, which is going to give us 16 is greater than x. And over here, if we were solving this with an equal sign in here, I think a lot of us would know that we just need to subtract a 5 from both sides. That's all we need to do. So treat it just like it's an equal sign and then go ahead and solve for x. So we get our two answers here. 16 is greater than x and x is less than 6. Well, do you guys notice this right here? On this inequality, x is on the right-hand side, but on this inequality, x is on the left-hand side. We can't have that. Okay, we got to have our x's be on the same side. So what we're going to do is I'm going to go ahead and flip this. I'm going to switch my x from the right to the left. I'm going to switch my number from the left to the right. And then I'm going to bring down this inequality sign. But if I flipped everything in this equation, what do I need to do with this inequality sign? Well, I need to flip this inequality sign as well. Okay, so we have x is less than 16. We also have that x is greater than 6. So there's a specific way that I want to write this out. What I want to do is I want to start with the smallest number, so 6. And then I want to go with the biggest number, 16. Now that I have our smallest number and our biggest number, I'm going to put the x dead in the middle. So right in the middle here of our 6 and our 16. So as long as we can remember how to set it up like this, you guys are going to be just fine when answering these questions. The next thing we need to do is put two less than signs. Put two less than signs. Okay, so just remember small number in the front, big number in the back, x in the middle. And our final answer is going to include those two less than signs. And what this reads is this says 6 is less than x, which is less than 16. So this is our range for the measures of the third side of the triangle. Last question here, we're doing one just like the previous one. So again, we're going to find the range for the measure of the third side of a triangle, given the measure here of two sides. So we're going to have 3.8, we're going to have 9.2, and if we don't know what that third side is, we will call it x. And remember, we're going to come up with two inequalities, one where x is on the right, and then one where the biggest number is on the right. So if we started off just like we did in the previous question, we'll say 3.8 plus 9.2 is greater than x. And then over here, what we're going to do is we're going to have the biggest number on the right-hand side. So x plus 3.8 is greater than 9.2. X plus 3.8 is greater than 9.2. So let's go ahead and combine like terms on our left-hand side here. When we do that, we get 13 is greater than x. But remember, over here our x is on the right, over here our x is on the left. So before we move on, I'm going to want to flip those. So just remember, when we flip them, we got to flip that sign as well. So this is going to be x is less than 13. Now solving the inequality on the right, we can subtract a 3.8 from both sides, and we will get x is greater x is greater than 5.4. All right, so now both of our x's here on the left-hand side. Now all we need to do is put that small number in front, big number in back, with a couple of less than signs in between. So 5.4 in the front, we're going to go 13 in the back with our x in the middle. Put two less than signs there. And that is our final answer.